Now, suppose you have an intervention for a psychology student that you believe is going to help improve their marks from the start of the semester all the way to the end of semester. And so you need to know how many participants you need in at the start in order to detect a difference of 0.20 on, for example, memory span. So we will give them a memory span task. Now, this is a within subject design, which means that the same participants are tested at the start of the semester and at the end of the semester. Now, you're interested in detecting a 0.2 or a coincidence of 0.2, which is a small effect size, at least 80% of the times. Which means that if I were to run the same experiment 100 times, I would be able to detect this effect size of 0.20 at least 80 times at an alpha level of 0.05. Now, if I enter these parameters in G-power, so I am looking to detect a 0.20 effect size with power at 0.80 at an alpha level of 0.05, my question is, how many participants do I need to detect that effect size? Now, let me show you how to run the power analysis for a within subject design. So again, what we need to look for is the appropriate test family. So because it's we're looking at two means, so pre and post, and that'll be a t-test, and then the statistical test will be a two dependent means, because the means are dependent on each other, because the groups are the one group is the same, so same participants pre and post. And then the type of power analysis, we're looking at a priori, so given the alpha level 0.05, given power at 0.80 and effect size of 0.2, we will require a sample size of, and that's what our power analysis will tell us. Details, you may leave it at 2 because that's more typical. The effect size is 0.2. The error probability, we leave that at the typical alpha level of 0.05, and power at 0.80. The power analysis is telling us that we need 199 participants in order to detect a small effect size of 0.2. Now, if I think that I am not able to recruit 199 participants, I can either decrease power, which means decreasing the probability of finding an effect of 0.2, or I could keep power at 0.80 and increase the effect size, and the number goes down to 34, which means that if I manage to recruit 34 participants, I will be able to detect a medium effect size of 0.5, 80% of the time, at an alpha level of 0.05. As I was explaining in the video on between group designs and power analysis, the choice of the effect size depends on what you're looking to investigate. So if you're looking to investigate memory span, and you think that an effect size of 0.20 is either clinically relevant or relevant to the real life context. So, for example, if you have an intervention and you think that your intervention is going to improve memory performance in psychology student, but you only really need to detect a very small improvement because you believe that that small improvement is going to really greatly benefit, improve their marks, and improve their academic performance, then a 0.2 is enough. But if you believe that in order to improve their academic performance, you actually need to improve their memory by a medium effect size, then you will need to be able to, or you will more likely be looking at detecting an effect size that's of the medium range. Now, the same, I will show you the same thing for the within subject design, the relationship between power and sample size. So again, when you've got a medium sample size, a medium effect size 0.05, and an error probability of 0.05, as you can see, as power increases, so does sample size. If I impute a small effect size, so I'm looking to detect a small effect size, the sample size changes dramatically. So in order to detect a small effect size of 0.2 at power 0.8, that is 80%, the sample size is now a lot larger than it would be if I were looking at identifying a 0.5 of an effect size. Thank you very much for listening. I hope you enjoyed this.